Hello, dear students. We've already completed 2 chapters. So, today I'm going to start a new chapter. That is the 3rd chapter, Understanding Quadrilaterals. Understanding Quadrilaterals. Yes. Actually, the word quadrilateral is not new for you. Yes, dear children. But before starting quadrilateral, let me ask, what is a polygon? All of you know what is a polygon? Okay. Yes, dear children. Yes, some examples. You can consider some examples here. Now you can see different shapes. Okay. Yes, one we can understand that these all are closed. Is it? You can see that these all the shapes are closed. Then let me ask one more question. Whether these are simple curve or not? How can we check whether it is a simple curve? What is a simple curve? Yes, dear children. Yeah, a simple example. Yes, first of all, we are very sure that these all are closed because starting and ending point same. Then here, a very simple figure. Here. Yes, starting and ending point the same. Okay. Here also starting and ending point same. And also these two are closed. But I am very sure that these two are not simple. Yes, why dear children these two are not simple? Nothing more. In these two figures you can see that the lines crossed each other. Is it? Yes, in these 2 points. So we can tell these two lines are these two shapes are not simple curves. Not simple, dear children, because the line itself crossed each other. That's why these two are not simple curves, but they are closed. Then, listen, dear children, in these examples, all the shapes are closed and simple. Is it? Not only that one, we can name it as, yes, this first figure, this one second, third, fourth, fifth, and sixth. Then, among these 6 figures, among these 6, 1 and 4 are not polygons. 1 and 4 are not polygons. Why? Yes, these all the figures are simple and closed, but the first figure and the fourth one is not made up of line segments. So, this one is not a polygon and this one is also not a polygon. Other all are polygons. So, what we can tell? What's a polygon? A polygon is a simple closed curve. It is a simple closed curve made up of line segments. Simple closed curve made up of line segments. Line segments. Okay. Yes. Next, classification of polygons. You all know that a least sided polygon is a triangle. That means a three-sided polygon. Yes, you know that if there are three sides, that is a triangle. Three-sided. If there are four sides, it is a quadrilateral. Four-sided. Quadrilateral means, yes, I am very sure that you may think that is it a square, is it a rectangle? Yes, these all. If a shape having four sides, we can call them as quadrilateral. And also, five-sided shapes are known as pentagon. Okay, then next, six-sided polygons are known as hexagons. Seven-sided polygons are known as heptagons. Okay, eight-sided polygons are known as octagons. Octagon. Next, nine-sided polygons are known as nonagons. Yes. Then 10-sided polygons are known as decagon. D-E-A. Decagons. Okay. Next concept study is diagonal. What is a diagonal? Diagonal. A diagonal is a line segment connecting non-consecutive vertices of a polygon. 1 minute. Yes. Now we can name this one as each point S or each corner A, B, C, D. This one D. Okay. Now we have to draw. How many diagonals we can draw? What is a diagonal? It is a line segment connecting non-consecutive vertices. Actually, this shape, this quadrilateral has how many? 4 vertices. First one is vertex A, vertex B, vertex C and vertex D. Yes, 4 vertices are there. What are the 4 vertices? Yes, here A, one vertex, B, another vertex, C, another vertex, C, another vertex, D, another vertex. So, there are 4 vertices, plural vertices. And, yes, it is a diagonal is a line segment connecting non-consecutive vertices. Consecutive here means is continuous. That means A and B are consecutive vertices. B and C are consecutive. C and D are consecutive. D and A are consecutive or adjacent. We can use another word adjacent. A and B are adjacent vertices. B and C are adjacent vertices. C and D are adjacent vertices. And A and D are adjacent vertices. Then we have to draw a line segment connecting non-adjacent vertices. Which are the non-adjacent? That means not adjacent. Which are them? Non-adjacent. Okay. A and C. They are not adjacent. Then, can you draw a line joining this? A and C. Yes. A and C. Okay, so AC is a one diagonal. Same way, another pair. Which is the next pair? B and D. Yes, join that. Yes, now we can see that there are 2 diagonals. Which are them? AC and BD. 2 diagonals, line segment AC and BD. Yes. Now for another shape. Yes, let me ask you a question. Yes, a triangle. Can you draw a diagonal for this triangle? Yes, first of all, we can name this one as P, Q, R. 3 vertices P, Q and R. Then P and Q are adjacent, is it? Nearer, that's adjacent. Q and R are adjacent and P and R. Yes, you have to identify, you have to find out two non-adjacent vertices. P and Q, P and R adjacent. P and Q, P and R adjacent. Same way, R and P, R and Q. Here we can't identify no non-adjacent vertices, so we can't draw what a vertices. We can't draw a diagonal here. Is it in the case of a triangle? Okay. Next, interior and exterior. Yes, you all know that interior and exterior of a mathematical shape. Yes. Listen, dear children, how can you mark interior and exterior? Yes, that means for any closed shape, the region or the part inside of that closed curve is known as interior. Here, if I am marking the point A, point B, what we can tell? Now A is in the interior and the point B is in the exterior. You all know that interior and exterior. Okay, nothing more, dear.